One of the topics that we unpack often with the districts that we support is fluency. I feel like it is a big topic right now, probably paralleling the work that's happening in literacy around just to focus on foundational skills right now. And I don't think anybody, whether, whatever side of the debate you're on, nobody thinks that students shouldn't be fluent. Like that to me is universally understood that, of course, we want
Right.
students to be fluent and flexible.
Right.
But I was asked a question the other day that got me pondering, and I wanted to bring it to our conversation today. We often hear different terms when it comes to fluency, right? We hear procedural fluency, we hear computational fluency, we hear fact fluency. And the question that I was pondering is, what's the difference?
That's interesting.
And then someone's like, is there a difference?
Yeah. Well, and when you say certain things like fact fluency versus procedural fluency, to me, what pops in my mind right away is those are actually different, but is it the process that's different, or is it the thing that you're actually fluent with different? So for example, when we talk a lot, John, you and I for many years had been talking about how we taught very procedurally, right? So we memorize steps and procedures. And when I think about that, that's very different than, say, fact fluency, where fact fluency, I'm looking at that as something where we're talking about, probably more of those basic facts, multiplication tables, some of the division facts that you want kids to sort of know, and even addition and subtraction that we want students to sort of know with automaticity. So, I look at those two and I see those as very clearly different. But as you kind of lay out all of these other scenarios and the way we describe some of these things, I think oftentimes we believe they're interchangeable. Yes. And sometimes that can cause some confusion as to how we might go about them. So I'm really excited to dig in.
Well, I think like the way that you've, just tried to clarify, procedure, like what fact fluency to you was, and thinking about like these facts, but then there's procedures, which is I think you were saying we taught procedurally, but it's like, so I'm leaning towards like being fluent in procedures. But I completely agree that someone and most teachers are saying they're all the same. Like we're talking fluency. So that to me, that means like what popped into my mind was automaticity. It's like, I just know it. And that's what we're really after. I just want kids to know it. And it's like, that's fluency. So then therefore it's like, well, what's the difference between all three of these? Is fact fluency automaticity? Is procedural fluency automaticity around procedures? Is, like there's these kind of terms. And I think, and then here's the other question is like, do we need to know what all three really mean? Like, what do we need to know that? Like, there's teachers asking that. Isn't it all the same? John, Kyle, Yvette, like, is it worth our time here? Okay, let's dig in. Yvette, you're up. Like, let's first maybe unpack the differences here between all three with some smarter minds other than
at least as we know them or as we believe them to be now, right? We're again reserving the right to learn and change our thinking down the road.
Loosely held.
Well, I went to Figuring Out Fluency from Jennifer Bay Williams and Giovanni to do some relearning. I've read the book more than once, but it's like I need to go back to it over and over again to make sure that I deeply understand. So I think that the way that they describe the difference is the scope. Okay, and they show it in almost like they're nested. So they're interconnected because they live within each other, but it's like there's almost like the scope, it's larger and larger. So let's start at the bottom. So Kyle, you described fact fluency as like basic facts, automaticity, and they describe it very similarly, and they say it's facts with single digits. So it could be like a double digit by a single digit, but whenever there's a single digit involved in the computation, that would be a basic fact. So even 8 times 10, 9 times 12, like these are basic facts. Computation involving a single digit. And I think that to your point, these are facts that ideally are automatized. They require no
they might not. So here's the worry part, right? Is that it's like, wait, those are facts, therefore we should just fact drill them in.
Yeah.
And not actually work on the other two pieces to actually help them become fact fluent. So help me understand this is like, because they're intertwined, is there like, I feel like there's this like Cascoing flowing model here that like
it's a
goes like, hey,
flywheel,
this
John.
flows into this. Yeah, flywheel.
Yeah,
It's
you
like,
like to
when
talk
I
about
build
the
this,
flywheel.
I get more of this.
Well, let's describe the other two
Okay,
terms first.
good.
So, fact fluency is, automaticity and not memorization, but automaticity of basic facts. Next is computational fluency, which is a larger scope because it's basically fluency with all four operators with a variety of numbers, right? So it could be double digit, 3-digit, decimals, fractions. Like we're talking about operating with all four operators. And this is where we really start to see, strategies, like, because these aren't straightforward computations. They're not, I can't necessarily automatize all of them. I'm going to need to rely on my strategies in order to be efficient. Procedural fluency brings in all of the other procedures beyond just computation. So it's finding the area of a triangle, it's solving a proportion, it's geometric properties. Like
It's like a recipe
more,
to do
completing
stuff.
the square.
right.
Yeah.
It's more complex than computation alone.
Got it. I like the recipe idea, Kyle. That helps me kind of like think about the difference. It's like if I need a recipe, my step-by-step algorithm, and that's a difference between like just multiplying 2-digit by 2-digit. Because to me, it's like, well, there's a procedure to multiply 2-digit by 2-digit, but what you're saying is that is more computational fluency to know those steps versus the more complex procedures like recipes to solve problems or to find values out.
Right. And even that computation piece. And I like the nesting. Like I've got that visual in my mind right now. Hopefully people are listening to this and kind of envisioning where this is, if you want to be computationally fluent, you're going to need those basic facts, right? And otherwise you're pulling a calculator out to try to, utilize what you know about computation, right? So they all kind of build off of each other. And I think that's going to be really important here. And I'm still picturing this as a bit iterative as well, right? Because we can do all of this work very early on at an appropriate stage, right? So certain students in kindergarten or grade 1, when we're trying to develop their procedural fluency, we want them to be able to apply some of the facts they know, some of the computational skills that they have and the fluency there, and be able to use it to come out with, that finished recipe, right?
Yeah. Like I'm imagining like, because when I think about procedural fluency specifically, and as a high school teacher for 20 years, and I think a lot of my early years were like, I was probably viewing like, I'm not here to teach fact fluency. I'm not here to teach computational fluency. I'm here
Or
to
they're
teach
supposed to have it,
Like my job was like, but I never said this out loud because I never thought about it this way, right? But I was like, I was teaching procedures, and that was what I was highlighting every day. It's today we're going to learn about how to find the slope of a line, and here's the process on how to find the slope of the line. Let's now go through that example, practice. Let's take note. Like I was probably thinking mathematics to me is teaching procedural fluency so that we could have the procedures down so that when I see the scenario, I can apply the procedures to solve the problem. But I was always like, I'm not going to like fractions show up in this question here. Just get your calculators out because that'll speed up the process so that we can better accumulate or better attain the procedure, because that is the be all end all here, and not say understanding computational fluency or fact fluency, because that's where I put the value. And I think we all, like when we think about what math class is and we're hearing about our classrooms and say traditional teaching, I'm using air quotes here, I think this is where I think a lot of us think is like procedural fluency is that's what we're really doing here in class.
Well, and John, how often when we were trying to, again, find the slope of a line where we're doing some pretty basic math, right? So basic facts that we want students to know, like, Y2 was 9 and Y1 was 6, and kids are getting out a calculator. And that would see, when I think of these tiers, I go, well, that's basic facts that student's struggling with. Yet we're trying to get them to understand a recipe for something much more complex. And I can totally relate to what you described. It's almost like, going back to our recipe analogy here, that we were creating like line cooks that would just follow a process, maybe not know why they're doing what they're doing, but they would, we wanted them to be able to like get the food down the line instead of chefs, right? Like we actually want students to be able to like think on their feet and be able to utilize some of these things and know, hey, when it doesn't taste right, like what am I going to have to do to make this better? And I think the three layers here, the three levels of fluency that we're describing, I think are all essential in order for that to happen versus someone sitting there sort of going like, now what? Like, now what do you want me to cook? Or now what do you want me to do? Right?
Yvette, let's answer this question. What does it look like when a student is fluent?
I think this is a question that a lot of our districts are trying to answer because we're trying to monitor how we will know when we've increased fluency across the district or across the school, across the system for both teachers and students. And so in order to monitor the impact of our action steps that we take, we need to know what the observable behaviors are so that we can notice and name them when we see them. And so again, I look to Figuring Out Fluency, and they've identified some actions, these observable behaviors that when a student is truly fluent or a teacher is fluent, you might see some of these things. So the first one is they select an appropriate strategy. And so the example that they shared in the book was 419 minus 297. Treating this as, and if there's no context, of course, and they're just working through the computation, and it's like, do they have computational fluency? If you have computational fluency for this particular subtraction scenario, you're likely not thinking about it as removal subtraction. You know, it's like, it really, because 297 is so close to 300, it's like I could just shift this up and I could just see the difference between 422 and 300. Like just like selecting an appropriate strategy, because I know that when I have a number that's close to a whole, so whether that's a 10, 100, a 1, if you're working with decimals, so I'd be looking for students to use an appropriate strategy. But again, like appropriate for me, it might be different than appropriate for you, depending on the strategy that you're most efficient with.
Yeah. Are you so like you're saying, like that's an element of like if I'm working with a student, or let's say I'm working with an educator and we're solving the, you know, that problem, and they select an appropriate strategy, am I demonstrating that I have stronger computational fluency over someone else, or am I like you're saying, because like earlier you said strategies live at the computational fluency level and not procedural fluency. So am I all after one versus the other, or am I just trying to, you know, witness where they are? Because I think if we have to answer, like, when have we got better on fluency? Like, where's the better lie?
I'm going to tell you when I would know that a student doesn't have this behavior. Imagine they were working through a variety of subtraction problems and they use the same strategy every time.
Right. And here's the interesting part too. I was going to throw this in there. It doesn't necessarily mean, like, my head went to, okay, so if a student uses the same strategy, maybe they're procedurally fluent. But in reality, they're not even procedurally fluent. They know a procedure. And that doesn't necessarily mean that they are fluent with the procedures that could be utilized for that specific scenario. So this is one of those scenarios where it's hard, first, going all the way back to John, you were saying, like, does it matter? Like, does it matter that we know the difference? And I think as we're digging in here, we're starting to recognize that we do need to know the difference, because we need to know what we're looking for. And most often, I think what's going to be most helpful is when they're not showing those signs. It could be hard. They use great strategy here or a great strategy there. It doesn't necessarily mean they're fully fluent, but it's definitely showing some signs that they may be, which is, I think, what makes this work so difficult. Because is there a finish line? And I'm going to argue there isn't. It's just continually trying to get more and more comfortable and fluent.
So, Kyle, because you said something interesting there about, like, they may not be procedurally fluent. So to you, are you saying, like, if I've memorized, you know, steps in a process, and every time I get thrown a question, I got that. Like, I just apply the process. Like, there's no numbers here that messes me up. Like, am I procedurally fluent then?
I would argue, personally, unless I can't think of a scenario where there's only one procedure to do a thing in mathematics, like where you know a procedure, that's great that you're able to follow this particular procedure. But when I think of fluency, I think of, like, could you do it another way? And that part makes me wonder.
So I just want to be clear for everyone listening too. So we're not saying like, I think what you're not saying is you're not saying like procedural fluency doesn't exist for like the one procedure or this procedure. It's more all encompassing than I'm procedurally fluent with completing the square. I am procedurally fluent with the long division algorithm. Like you're not saying that each process or each procedure we are fluent or not. More all encompassing. We're procedurally fluent with. So now I have to go back though, because like, what makes that different? Like because you were saying like computational, the strategies live at computational. So how do I know, like, what does it look like then when I'm procedurally fluent versus computationally
Okay, I got
fluent?
a
Because
scenario
if I
for you.
select a strategy, that's
Yeah.
indicating that I'm
Okay.
computationally fluent?
Here we go. I'm so glad
Okay.
you asked. I'm ready. I came ready with my example. So, as a team last week with our leaders, we worked through a problem. And it was a problem of the week from the University of Waterloo. And it was an area problem. Okay. So imagine it was kind of like Parks and Playground a little bit, Kyle, from Kathy Fosno's unit, where you essentially have a rectangular park and different areas of the park are different types of areas. So you have wooded area, you have play area, and you have open space. But of course, there were different sections shaded. So wooded area, maybe there's a triangle on the left and then there's a trapezoid on the right. And you're basically trying to figure out what area of the park is wooded, what area is open, what area is play. So this is where I think I can distinguish the difference. The procedural fluency was in applying our understanding of how to find the area of different shapes, how to find the area of rectangles and triangles and trapezoids. Like that to me was like how I was applying the procedure. It was executive functioning to solve the problem. It was a multi-step problem. It required different types of operations. And I was procedurally fluent because I was able to navigate. It's almost like the application phase.
Right.
The computational fluency came into play when I had to, for example, add two different areas of wooded and they weren't super friendly. I was like adding 122 plus 87, and I actually had to use a strategy to do that addition. So that was where like my computational fluency was at play. And the way that I added those two areas was maybe different from the way that I added the other two areas because the numbers were different. So I used different strategies depending on the relationships. I also used my fact fluency because sometimes I just had to multiply 6 times 10 and divide by 2 to find the area of the triangle. And that was automatized. I didn't need any steps.
So I think what I'm hearing from you there is that procedural fluency was like it's still about selection. So like you're saying fluency, your first example there with like 419 minus 297 was like when a student selects an appropriate strategy to solve that problem, they were exhibiting signs that they were more computationally fluent. But what you're saying is like when I have maybe a scenario or when I have a complex situation, the ability to fluently select the procedure amongst many procedures, amongst my arsenal, I've got my tool belt here.
And which recipe should I take out?
Right. So I have a lot to choose from. And now I'm more procedurally fluent because I can fluctuate and I can be fluent in choosing the right one at the right time, but also going like, I think that procedure works better than that procedure because of the numbers.
But it was also beyond just computational because I had to understand the properties of the shapes I had to understand the properties of a trapezoid to be able to understand how to use the procedure for finding the area of a trapezoid where actually I chose to subtract the two triangles. But it's like that's procedural fluency as defined by, it's like it's bigger. The scope is bigger. It's not just computation, it's application of computation through our other strands.
Well, I want to pause here for a second because I think it can be really easy for us to miss this, but I'll go back to your slope example, John. And when I think, or the way I was teaching back then, and all of the opportunities that students in my class were missing to develop their computational and their fact fluency, because we kind of like had the calculator there as the crutch because like we didn't want to like derail the lesson, when in reality, that procedural fluency, I would argue the students that were struggling with computational fluency and fact fluency and weren't being given the opportunity to develop those also probably struggled with the procedural fluency as well, right? Because like you don't have a solid foundation. You don't have confidence in what you're doing because you don't see the numbers. You don't see what's going on. And that's going to make, even if I'm like the best teacher at, communicating step by step what you need to do every time you see slope of a line, it's like they still just don't have this confidence to trust that things are going to go well for themselves because things always seem to go wrong, right? And that, I would argue, is part of this foundational piece here where really I now recognize that those procedures were actually not not doing a whole lot for students in my classroom when they weren't given the opportunity to strengthen the other two tiers or the other two layers here of fact fluency and computational fluency.
All right. What are some other look fors, Yvette?
I'll kind of go through them quickly and then maybe we can unpack them after. So these were the ones that were identified, and maybe pick some that you're like, I want to know more about, and I'll do my best. I'm going to obviously tell people go read the book though, because this is my interpretation of these actions at this time.
You're not that fluent with the book yet, exactly. Is what you're saying.
Yeah, exactly. So selects an appropriate strategy. I said, I would like to see students using different strategies depending on the relationships between the numbers. And so if a student used the same strategy every single time without looking at the relationship between the numbers or the quantities, that would tell me that they don't have true fluency. Solves in a reasonable amount of time. This one can vary, right? So the length of time it takes for a grade 4 student to add fractions versus a grade 7 student is going to be different. But the general idea is they don't get stuck or bogged down. So, they're not stuck or they're not overwhelmed, or really, it doesn't become really demanding. They trade out or adapt a strategy when it's not working. When they get, they go to apply one of their strategies and they're like, actually, you know what? This isn't going to help me. It's not reasonable. I'm going to swap it for another strategy that tells you they have fluency. This is one of my favorite ones. Another action is they can apply it to a new problem. So let's say, for example, we're doing addition 48 plus 56, and they use the compensation strategy to make it 50 plus 54. Can they apply that to decimals? Can they apply the strategy to new situations that are novel, but the properties remain the same? So now when they see 4 and 8/10 and 5 and 6/10, can they just make a whole and do 5 plus 5 and 4/10? They complete the steps accurately. So, of course, that's something we probably would have looked for in the past. Another one we would have looked for in the past, they get the correct answer. And I think the one that I love is they check for reasonableness, but not just at the end, throughout. It's like they're actually asking themselves, like, is this going to be efficient? If I decompose this way for my break apart to multiply strategy, is that going to be efficient, or am I going to get a fact that's actually going to be unfriendly? What's a different way that I could decompose so that I have more automaticity with this fact? We shared one recently. Remember when we were multiplying 20/40? And I was like, I'm going to do 25 and 2 because it's like 25 is really nice. But I probably would have started with 20 and 7 and then been like, actually, no, 25 is friendlier when I multiply by 4. I'm going to decompose it this way instead. So it's like checking for reasonableness, not just at the end, but throughout the process to make sure that your strategy is going to be most efficient.
Now, when I think about trying to witness this with students, it's like, okay, so we're going to look for appropriate strategies. Can they trade that? We have to also create scenarios where we can see that type of thing if we're looking for that type of thing. But when the work that we're currently doing, like we're supporting schools and school districts right now in helping each teacher build, their procedural fluency, computational fluency, fact fluency for their students. But I think what a lot of leaders right now, coordinators, math coaches are, not necessarily just realizing, but knew all along, is that a lot of our teachers, and especially us, like maybe we also need to strengthen that part. Like how many, when you say like trades out and adapts a strategy, how many, when you're working with teachers, how many are doing that on a regular basis when they're multiplying themselves, or are they just turning to the calculator, right? Like how are we doing that? Because like I think that's the crux right here, is like so many schools are trying to say like, we want to increase this, we want to increase fluency, we've got to know the difference between these three so we know what to look for. But do we also know what to look for when we're working with adults?
I wonder if solving a problem like the one that I described that we did with the leaders last week, in a PLC or in small groups in a staff meeting might start, whether that's, so imagine now we're talking about teachers. It's like we work through a problem collaboratively where it's a multi-step problem. It requires the application of procedures in another strand. There's going to be computation in there with double-digit numbers. There are going to be opportunities for some automatized facts as well. And we look for these observable behaviors. Because what I'm wondering is, imagine I did this with a student. I gave them that problem, a 7th grade student. I sat down with them and I gave them that problem and I just observed them and I talked to them as they were thinking through it. I feel like if I did that problem, I could probably get to the underlying issue. Like, is it with the procedure of finding the area? Like, they don't understand the visual relationship between, the rectangle and the triangle or the trapezoid. Like, so is that where we're falling apart here? Is it in the actual computation when they got to some of the more challenging addition and subtraction, they just didn't have a strategy without a calculator, or they were using an inefficient strategy? Or when I saw them, it's like maybe they know how to find the area of a rectangle, but they couldn't multiply the single digit numbers.
Right.
So it's like, I think that if we engaged in a task like this as an entry point, and you talk about this all the time, like start with the task that is a high cognitive demand and application task. And then once I've observed those behaviors, I might be able to diagnose, like, where are we falling off? Is it that we don't know our basic facts? Is it that we don't have strategies for computation when the numbers become more complex? Or is it that we actually don't understand the procedure of how to
all the above?
Yeah, well, and I was going to say, like, I'm envisioning when we're working as a group, I put us in the same group of educators as we're trying to learn and build our content knowledge. If I had to put money on it, I'm going to say the part that we are probably needing most attention is going to be in the middle, which is that computational fluency, right? It's like most of us are pretty good with, a good chunk of facts, and most of us are pretty good with a certain amount of procedures and maybe even where we might apply those procedures. But it's that middle ground that I think we're probably needing to focus our time and attention on. Because without us having that, we can't provide those opportunities for students in our classroom to develop their computational fluency as well. So this is really interesting. I've had some mini epiphanies here as we're working through these 3 layers.
Well, I think I would say all of the districts that we're currently working with, supporting, and talking with on a regular basis, we talk with lots of districts and lots of schools, and every single one of them will have said that fluency is a major focus. It's an objective, or it's a major area of focus for the work that they're trying to do. And you have to ask yourself, like, okay, even if we know the differences between the 3, and we know some strategies to help students develop this, if we're not also developing those strategies for the educators, but then having the set of, like, the look-fors that you talked about, Yvette, being like, do we know what we're looking for? Because down the road, you're going to want to know, did we improve fluency? If it's one of our objectives, if it's one of our focus zones, is how do we know that we made improvements this year? Like, we want to work on it, but it's like, do we just look at student test scores and that's going to tell us? Probably not, because there's a lot of cloudiness right there from one year to the next. And especially if we know that what you just said, Kyle, is that probably a lot of our educators we're working with need to strengthen their computational fluency strategies and their fluency up so that they're better positioned to do this with their students. It's well, how do we know we did better there? Like, how do we know? And that's why making that look for list, the walkthrough list, like, what does it look like when a teacher is more fluent and therefore in the classroom teaching lessons, because really those are the look fors you're going to want to look for, right? So it's like, if I'm gonna math coach or coordinator and I want to be able to answer that question, did we improve or get better? Are we stronger as a system or as a school on fluency in these grades? When I walk through classrooms or I work with teachers, what am I looking for to know that we've made improvements there? Because I think it looks different from, like, I'm clearly solving problems and I'm demonstrating that I'm computationally fluent, I'm procedurally fluent, or I'm fact fluent as a learner. But as an educator, I think there's in a way, a slightly different set of look fors, because when you're in the classroom, the teacher is the one not doing all the computation. But you know when you walk into a classroom whether that teacher has strong fluency across all 3 areas or not.
Well, the part that, for me, I think is really important for those who are listening right now is to kind of zoom out a little bit and think about what it is that you are working on in your classroom, in your grade band, in your school, in your district. And if you think about that, we always talk about trying to get clear, right? And we try to get narrow. And when you think fact fluency or just fluency in general feels pretty narrow, right? It feels narrow. But what I think we've just highlighted is that it's not narrow enough. And what we really need to identify is what specifically are we looking for? And then I also want to rope in some others, because there's lots out there, a lot of the districts we work with that start with problem solving, right? Or they start with, building, the skill around problem solving. And think about how important these three, pieces, these three types of fluency, how important they are in order to be able to become a strong problem solver, right? So the question then becomes is it really problem solving? Is it something else? Is it something deeper than that? And as we get deeper and deeper, and as we better understand what's really going on, we can then identify the more specific changes that we can make in order to build our own content knowledge, and then be able to actually implement some of these things in our classrooms, so that we're not focusing on something that's broad. And John, at the beginning of the episode, we said a lot of times people kind of look at it as this one thing. And the reality is that it's actually not. And in most cases, I would argue there's always deeper. We can always go deeper. So when you think you're at the answer, there's probably 5 more questions to ask to get deeper and deeper and deeper, so that you can get to the real root, the real problem, the real pebble that's in your math leader's shoe.
Speaking of pebbles, I'm going to share one that many of our districts are facing currently, and it's similar to what we're facing in literacy as well. It is very hard to monitor fluency without sitting one-on-one with students. And so when you're trying to system-wide support the implementation of any type of screening tool or diagnostic or collection of student thinking or growth, this is maybe a pebble that people are experiencing, is that and I know that I've seen Jennifer Bay Williams speak before as well, and she talks about how we can monitor fluency, and it's the interview style, sitting and observing students, asking them about their metacognition is always going to be the best way. And that seems to be a hurdle that some of our districts are facing, is, buy-in that this is time well spent, or finding a place for it within the classroom. But I always, one thing I always go back to is it doesn't need to be, 30 questions that kids are solving. It can be one problem, and you visit every student in a week to see them work through that one problem, so you can really gather some good evidence of their thinking and identify where is the breakdown happening.
Yeah. And I think it's also hard when you don't know what you're looking for, right? So you have to be clear to yourself. What am I actually looking for here in this situation with this student? If I'm a leader, I'm a coordinator, what am I actually looking for when I want to answer this, the question of, are we more fluent as a school or a grade band or a classroom? We want to be able to say, what are we looking for? And that starts with defining that look for list, and then also monitoring that look for list. Are we getting better? Are we stronger? Usually the teams that we're working with are developing continuums that they can see growth on over the course of a time or timelines that they're looking to strengthen. And these are bigger issues, because it might not necessarily be fluency or procedural fluency or computational fluency that you're actually looking for growth in. No matter what, no matter what you're trying to improve, you have to get clear on what is it that I'm looking for to see improvement. Can I define it so that I can then look for it and measure it or capture it? And this is an important process. This is school improvement planning process. It's a thing that you have to be going through every single year of how do we define what we're looking for? What are we looking for growth? How do I know that we've happened? It's part of our 4-stage process, and it's the beginning. We have to get clarity there, and we help teams do that. And that's why when we say we're working with schools and school districts, we're helping teams develop the clarity around what is it that they're trying to improve, and what's the process that they can install into their school system or their operating or their districts or their classrooms, so that they can see progress and get traction along the way. That's what we're trying to do here at Make Math Moments and the work we're doing. So if you want us to have a peek and talk to us about what you're currently doing to answer those questions, or what your look for list looks like, or your tools that you're using to monitor progress. Let us know. We'll hop on a call with you. You can book a call over at makemathmoments.com/district. And we can be talking about what those measurements look like. And you can be able to answer at the end of this year, are we making progress in strengthening fluency at our school or in our school district?